today is rotation. Oh, yeah. Are we ready to rotate?
Yeah.
What does that mean?
Rotate.
Oh.
Spin.
Oh yeah, Miss Rob, you get it, girl.
We'll do it 360.
Do that again.
Yeah.
There it goes.
I get a little dizzy though. Okay, I think you're like when you were in taking dancing, you would spot, right?
Okay.
Wow! There we go. Did you see the little doing?
Yeah.
I took dance classes when I was a kid.
So does Lily. I wonder if you were like her dance teacher.
No.
Oh, like or in her dance class.
I took no. I think we have a bit of an age difference, but thanks. All right. So rotation. Now I will say, like, so I like to think of the pinwheel, and the reason why I like to think of the pinwheel is because essentially, like, this little triangular shape is the same, and it's going around a point, right? Does that make sense to everybody? So that's what we're doing. We're taking the shape and going around the point. So let me see if this works. Oh, come here, Cammie. Let's do it. Let's do the Pac-Man.
Did you play Pac-Man, Miss Rob?
I did play Pac-Man. That was like my my stuff. Okay, here we go. Page 7. Okay, so this is our last rigid motion.
Oh no.
Okay, so we did translation, we did reflection, and now we're on to rotation. Okay, so what is rotation? Rotation is going to be spinning or turning a shape around, and this is the part that's important, a fixed point. So I just get that written down for you. There we go. Whoop. A fixed point.
So like the 1 point stays still, just move everything around it.
Yes. So that point may or may not be attached to your shape. Okay? So on a pinwheel, the corner of the shape is attached, right?
Yeah.
But if we have something spinning farther away from the center, then it's like kind of floating out in space, but then that still stays the same distance from the center. Like if I were able to raise my arm but keep my hand out here, right?
Yeah.
That's kind of like the idea.
Yeah, I don't think that's good to everything.
No, it's probably not. Okay, so our details, and this is probably the hardest one to remember all the details. Because translation is like, yeah, I'm moving it to the left 2. I'm going down 5. Like that's pretty easy to like, you see, just explain what you see. Reflection is only a line that you have to say, right? But there are 3 details for rotation. So the first detail is the direction of rotation. So are you going, and tell me if you guys need me to write this out or if we can abbreviate, are you going clockwise? Is that good? Do people understand CW, or do I need to write it out what it means?
I think
We're good? Or what's the opposite of clockwise? CW, counterclockwise. So that's the first thing you need to tell somebody. So hopefully you all know those directions. There is typically an analog clock in every room. So you can always look up at the clock, and clockwise is the direction the numbers go. Counterclockwise is the opposite direction. So that's the first thing. The second thing is the center of rotation. A lot of times it is the origin, but it's just a point. And like I said, it could be a point on the shape, not on the shape. It could be the origin. It could be a different point, okay? So it's a point in space. This is the one we usually forget. So don't forget me. Don't forget me. And then the last one is kind of like that idea of how far, okay? But when we're rotating, we don't talk about left and right. We talk about the direction, and then we talk about the degrees of rotation, okay? And typically, we are using these degrees because of our quadrants on the coordinate plane. It's going to be 90 degrees or 180 degrees or maybe 270 degrees. This is very rare. And then if it's not on grid, we can talk about mapping, but we'll get to that in a little bit. Like just say you're rotating such that this lands on that. Okay, but then we'll deal with that part later. All right, next thing to say. So orientation of the letters, does it stay the same or does it change in a reflection? So we go up here, and so now this is where things also get a little bit goofy because we're doing rotations about the origin, we're doing rotations within the shape kind of, but you're just looking at the letters. So A, B, C, A, B, C, A, B, C, A, B, C. This is clockwise, right? So that's why I like to put that information inside the shape. Does that make sense? And then this one, A, B, C, A, B, C, A, B, C. Is it still clockwise? Yes.
Yes, it is.
The only one that's going to change it is reflection. So the answer is yes.
What is orientation of letters?
So orientation of letters is the fact that these letters, I'm gonna do an example here. So don't write this down yet. I'll explain in just a minute. And you don't necessarily want to write it down here because I have something else to do here. Okay, this rectangle-ish shape I'm gonna call A, B, C, D. Okay? Say I reflected over this line. The D would be here.
Yes.
The C would be here. The B would be there. And the A would be here. Okay. So say I go back up here and I name the shape and I go A, B, C, D. If I go to the A here and I go the same direction, A, B, C, D, do I hit B second?
No.
No. So that's orientation.
Okay.
Orientation is reversed when you reflect.
Okay.
Does that help people?
Yep.
Okay, because I have to now go this way to get to B. A, B, C, D. Okay, so I'm going to erase this because I wanted to use this space to talk about, is it a rigid motion? And so the answer is yes. What are some words we can say for explain why? Why is it a rigid motion? Yes, because rotation does what to the shape? It does nothing to the shape, you're right. So what if it does nothing, then it preserves, right? Because rotation preserves. The easiest thing to write down is size and shape. Like, so that's your go-to if this is hard. It preserves size and shape. It's a rigid motion because rotation preserves size and shape. You can also say preserves side length and angle measure, or you can talk about corresponding sides and angles are congruent. Okay, but this is perfectly fine. All right, so before we walk away from this one, couple things that I want to show you. You don't have to necessarily put this down. Can you guys see that this arrow is telling me I'm going in what direction? Counterclockwise. So this is going to be counterclockwise rotation. It's going from quadrant 1 to quadrant 2. And so typically to figure out how far a rotation is going, you can count the quadrants. So one quadrant rotation is 90 degrees. And then it doesn't, there is. Here is the point D, right? It's centered at the origin. That's 0, 0. It looks like an owl, but it's really 0, 0, the origin. The owl eyes, right? Woohoo! Woohoo! No. But this is what I want you to see. I'm just going to go from the center to point A and the center to A prime. Do you see now the 90-degree angle? That's what it means it's moving, rotating 90 degrees. it's not that B is a right angle, and I don't even know if B really is a right angle, but it's because this is 90 degrees. That's why this is 90 degrees. Every point, and we just move the vertices, is going 90 degrees. Now, we're not going to fill in the table down below here yet. Basically, there are beautiful rules that start off with X, Y rules, right? For 90 degrees, 180 degrees, and 270 degrees. They end up becoming kind of obvious as we do things like turn our paper. Think about the signs in each quadrant. So we're not going to fill these in until we play a little bit, okay? Which means we might fill them in after lunch. When you're ready, you're going to go turn the page, right? That's the end of that page. And we have until 10:59. We got 10 minutes, okay? So let's look at our first example and digest what it's asking us to do. So in my opinion, performing rotations is the hardest one. Typically, you don't have to perform, you have to interpret. But until you actually practice it once or twice, it's hard to understand what is actually happening to the shape, okay? So here we go. It says graph and label triangle A prime, B prime, C prime, the image of ABC after A. So here's our details. Rotation, 90 degrees, counterclockwise about the origin. So the word about means centered. It means the origin is fixed, but the other stuff is not. So I'm going to put a point on the origin to know that that's my center. A is closest to the center. It will be the exact same distance away from the center as we rotate it. We are in quadrant number 1 right now. Agreed?
Yes.
Okay, if we go 90 degrees, we're going from quadrant 1 to quadrant 2. Next thing to notice, all the points in quadrant 1 are positive X and positive Y. But in quadrant 2, they're negative X, positive Y. So negative X, positive Y. Okay. And then the last thing I'm going to say before I need to take a quick photo of this and turn it for you is rotation does not equal reflection. Okay? If it looks like you've reflected, you have not rotated. Okay? So if you're trying to do it, just pause for a second. If you have, do you have pencil or are you working in pen, Scooby? If you need a big eraser, let me know. Okay, so now just let me do this little trick on my screen and it'll just take me a second. And if this is all we get done before lunch, this is all we get done before lunch. So I would rather have you understand it than just jump and do it. Okay, new. Here we go. Okay, great. File, save. Save. That looks great. It's in my pictures. Love it. Save. Okay, great. Now I'm going to go to add media from my computer, from my pictures. Open. Drop. Okay. Come here, buddy. I want to move you. Oh, it's not going to let me move it. Come on. Okay. Sorry, it's being cranky. Oh, wait. No, yeah, I'm on the right thing. Okay, I'm just going to expand it. There we go. That's kind of right. Okay. So I want you to watch what happens. If you can do this with your paper. So if you take your paper and you turn it like this, Did you just turn it 90 degrees counterclockwise?
Yes.
Okay, great. So watch what I'm gonna do here with this little picture. I'm gonna do it. Okay. Do you see how the triangle is pointing to the left?
Yes.
Okay. Do you see how if I were to get to point C, I would go back 5 and up 4? Does that make sense? To get to B, I go back 1 and up 4. Okay.
What do you
So,
go back and up with?
so let me turn your paper upright. It's okay. Turn your paper upright. I need to find a pen. I lost my pens. Let's write down the coordinate pairs for A, B, and C right here. The original A. There we go. The original A, the original B, the original C. On your paper, look at your original paper. A is located at 1, 1. Do you guys agree? B is located at over 4 from the origin up 1, like you're plotting point B. C is over 4 up 5. Does everybody agree that that's the original location? Okay, now, this is your paper turned, correct? So, focus. To get to A, do you see how I'm going back 1, up 1? So that's the coordinate pair, -1, up 1. Does it make sense that if I'm in quadrant 2, it goes negative, positive? Yes, okay, so let's see what's going on with B prime. B prime is back 1, up 4. Back 1, up 4. So the negative positive makes sense. Look what happened to the X and the Y.
They swap.
Do you see that they swapped? So now you can predict where C prime is going to be, or you can actually just do it. Back 1, 2, 3, 4, 5, up 4. Back 5, up 4.
So would it be? Oh yeah, that's what I got.
So now I plot my shape. Back 1, up 1, plot my point. Back 1, up 4, B prime. Back 5, up 4, C prime. Do I see a triangle that's pointing to the left?
Yeah.
Do you see kind of the pinwheel idea? Okay. All right. Here we go. So I erased it. I'll get it back in a second. Okay. So now we're going to go ahead and graph and label the double prime. So when you have the two little guys, it's double prime of the original. So we're going back to the beginning. After a rotation of 180 degrees, we actually don't need to say the direction because going 180 this way is the same thing as going 180 that way, right? It doesn't matter. I'm still facing the board then. Okay. About the origin. So here's your paper. Turn it upside down. So look at your original triangle. Do you guys see that it's down in quadrant 3, which is, you can write this in a second, negative, negative land. Do you see how your triangle's pointing down instead of pointing up?
Yeah.
Okay, so turn your paper back up. And I'm going to put my media back on here in a second. So we have we have ABC, which is still our ABC from the very beginning. 1, 1, 4, 1, 4, 5. Now, we know that everything is going to be negative, negative, because we're going into quadrant 3. A double prime, B double prime, C double prime. So we know that A, because we don't know about the switchy thing yet. Does the switchy thing happen? But we know that A double prime has to be -1, -1. Does that make sense? Yeah. Okay. So if I go and put I'm using purple's good, A double prime has to be here. But now I need to figure out what's happening with B and C. if B is over here, it's not going to land down here, right? That feels weird. If you turn your paper upside down again, do you see how AB is horizontal,
Yeah.
right? So B has to be over here. So it's going to be back 4, down 1. Back 4, down 1. Do you see how they don't flip-flop? They just both become negatives.
Yeah.
And then the last one is going to be back 4, down 5.
Wait, so what just makes the other one negative?
It just, all it's doing is, so when we go to rules, this rule for 180, the 180 rule is just negate. Change the signs on both. Don't switch the order.
Wait,
For,
I just have a question then.
yep,
And how is C prime and C double prime?
-4, -5.
How are C prime and C double prime different? You swap them back again. Like,
So C was 4, 5, right? And now it's -4, -5.
okay, so if you're going from C prime to C double prime, you swap them back again.
If we're doing a 180-degree rotation,
Okay,
you don't swap the numbers at all, you just make them both negative.
so it'll be the same as the original one.
Mm-hmm.
Starting there. Okay.
Yep. So B double prime, A double prime. That was a little bit faster than I wanted to go on that one. But the deal is there's these beautiful patterns which you can see if it's right or wrong, right? Does everybody see the pinwheel happening now? Okay, beautiful. At this point, just take a deep breath and go to lunch.
They had you.
All right. Is everybody all right over there? All right. So I just gotta go here, right? So on this page, we just finished 90 counterclockwise and 90 counterclockwise, and we notice there's these patterns, correct? With our coordinate pairs, they only work if the origin is the center. Okay? So on the previous page, we had this box, right? So just turn a page back in your notes. Turn a page back in your notes.
Oh.
There you go. Because now we know the rule, right? When we did the 90, we know since we were moving one quadrant, the first, this is going to be a Y and this is going to be an X, but one of them has to go negative. And so when you go back, it's the first coordinate that is negative, right? Okay. And then for the 180, the coordinates didn't switch at all, but they both went negative. Negative X, negative Y. So I'm wondering if you guys can predict what 270 does. So if I go from positive to what are the signs in quadrant 4? Positive, negative. So we know it's going to go positive, negative. Yeah, so it's going to go Y, comma, negative X. So when we go to do reflections, and we did reflections, we saw that there were rules for x-axis and y-axis, and the line y equals x and y equals negative x, but it's hard to memorize them all because it's like, what's going on? So, but this one is kind of cool because there's the flip of y and x, and there's some negating depending on the quadrant. The other thing is they don't have to do counterclockwise, but obviously 90 degrees counterclockwise is the same as 270 clockwise, right? Same thing down here. And they don't have to put direction for 180 because you get there regardless. Okay? All right. Does everybody have this box filled out? You working on it, Lena? Okay. So then what we're going to do is we're going to continue doing some more examples together. I've decided that we're just going to keep working and I'm not going to give you a homework assignment tonight.
Thank you, Ms. Rob.
And then, which means we're going to work till the end of the period. Okay, so we can get this lesson done. I'm also going to move to the document camera. I think it'll be easier for you to see what I'm doing. But if you guys want me to switch back to the board, I can. Okay, so just holler if you need me to switch. Okay. So I'm going to go over here and just get myself in position. Ow. Oh, that hurt. Okay, so we finished this one. We're now down here on the bottom, right? Okay, and this part is literally just a piece of vocabulary. So so light on or
Wax on?
light off?
Light on.
Light on?
Yes.
All
Thank
right.
you, Miss Roberts.
And then is it blurry or is it pretty clear? It's pretty
I think
clear.
it's pretty clear.
Okay, so here we go. So up above, up here, you guys have a triangle in this thing. It looks like this, right? Right, like that. A double prime, B double prime, C double prime. All I want you to do is plot that triangle again right here. So you had -1, for A double prime. You had B double prime was over here at back 4, down 1, B double prime. And C double prime, this was a side length of 4 or you're down 5. Okay. Okay, so we have learned translation, which is a slide, reflection, which is a flip, and rotation, which is a turn. But there is also this thing called, wait for it, point reflection. What? What's a point reflection? So a point reflection is literally having, and I'm going to use the origin as my point I'm reflecting through. I literally take, for example, point B to the point. I should have straight edge and I don't. So like I take point B to the point and then I reflect it to the other side. Do you see how this piece is equal to that piece? And the origin is in the middle? The thing, so it comes up maybe in a single question, in the whole entire situation. Basically, point reflection is the same exact thing as 180-degree rotation. That's all you need to know. Point reflection is the same thing as 180-degree rotation.
Is it point rotation or point reflection?
So up here, this word point reflection, and I did it specifically through the origin. And so you can I need a straight edge so you can see what I'm doing. If I do 180-degree rotation, so I'm going to see if I can get one of my other colors to work here. Is red working? Yes. And I connect two corresponding points, like C to C double prime. Do you see how it goes through my center of rotation? And that origin to C is the same distance as origin to C prime. That's all point reflection is. So they just might throw it in as a vocab word. Tyler, class is here, not whatever you're doing on your Chromebook. Friends, do not make me a crazy person because I will start getting poopy angry.
Hey, you're welcome, Miss Roberts.
All right, so now are we ready to keep going? We got 2 more to do. The problem is I somehow this line of words got stuck on this page and not on the next page. So our next topic is when the center is not the origin, turn the page, bring the origin to the center of rotation. So basically what that means is the center doesn't equal the origin right now. And let me get back on the screen. Sorry. The center does not equal the origin. So we are going to draw new axes. It'll all make sense. Okay, let's read question number 4. It says graph and label triangle A prime, B prime, C prime, the image of triangle ABC after a rotation 90 degrees counterclockwise, but wait for it, centered about point A. So point A is the center. Think about the center of the pinwheel. Did the center of the pinwheel move? No.
No.
So since point A is the center, point A is fixed. It's glued. Hello, sir. Do you have a Chromebook? Yep, so you can, why don't you go sit over on that side of the room? It's a little bit, there's an empty table. Open it up. It should be in the Google Classroom for you to start. Okay? Cool. Okay. Let me know if you can't find it. Okay. So now, point A is fixed. Next thing. We are going to draw a vertical and a horizontal set of axes through A. So I'm going to go to A. And I'm going to draw a horizontal line. So this is good where if you have a color or something, this is nice. Your highlighter might be too thick for this. It's totally up to you. And then I'm going to draw a vertical line. Okay. So a colored pencil could work. A colored pen could work. Okay. And what this allows us to do is determine that we're going to rotate 90 degrees, right? We're still going to go that way. We then might remember that we're going from positive land, right, to negative positive land. And this is the best example of reflection can't be equal to rotation. Okay, so you know that your coordinate pairs are going to be the same numbers. You just have to figure out, are they going to go flip, right? You have to, like, this is why you don't memorize the rules. Are they going to stay the same or do they need to change order? So off to the side here, we have B. Now, we're not going to write down B's location in reference to this origin. Does that make sense? Like that's the real origin. We're going to write down its location based on A. So B is located over 2, up 3. Do you guys agree with that? Which means you kind of just have to decide, do I want it to be back to up 3? Wait, no, I don't want that because that's a reflection. Can you guys see that?
Yeah.
I want it to be back 3, up 2.
Because that means it's playing upside down.
It's not going to point upside down.
I'll play this one.
It's good. So you have to, so you see, if I turn my paper, do you see how it's going to be like C is pointing up? That's what it's going to end up being. The B is going to be farthest to the left. Okay, so I'm going to go to A, and I'm going to go back 3 and up 2. I'm ignoring the normal axes, and I'm just going to put B prime on here. Okay. Now I'm going to do C. In reference to A, C is 1, 2, 3, 4, 5, 6, comma 1, right, from A. So that means in order to go 90 degrees, I don't want to put it way over there, right? I don't want to reflect it. I want it to go up there. Can you guys see that 90-degree angle when I put my pen this way?
Yeah.
Okay, so that means it's going to be back 1, up 6, C prime. So I go to A, and I go back 1, and up 6. 1, 2, 3, 4, 5, 6. I'm way up here. C prime. And A prime is the same thing as A. Okay, so now I'm going to connect and make my triangle. And this is the true pinwheel because it's attached.
Mine looks like I did reflection. What? I know I can go.
Do you want another copy or can you erase?
No, I can erase.
Okay.
I was just like,
So yeah, so that goes back to the whole idea that rotation cannot be reflection unless like you're rotating a square, right? If you're rotating a square, it's possible that it could look the exact same and it's like horizontal vertical, right? You're not going to notice the difference. But now what happens if they asked you, where is C prime? Like what's the coordinate pair for C prime? Your answer can't be this, right? You have to go back to the origin to find its true location. So remember, here's the origin, 0, 0. You didn't rotate around that, but that's how you describe space. Were you able to find the quiz, dude? Good, okay. So if I want to get to C prime, I'm going over 1. I'm going positive 1, right? And then I got to go up a whole bunch. Now it's labeled every other 2, 4, 6, 8, 10. You're right, 11. So 1, 11 is our true location. Based on the coordinate plane, but we use our different set of axes to make rotation easier. Thumbs up? Okay. One more to do and then we're done. Okay. So it says graph and label triangle A prime, B prime, C prime. The image of, you don't need the word original in there. That's kind of a typo, but it's okay. A, B, C, after a rotation 180 degrees, centered at the point 0, 1. Okay. So the first thing I need to notice is that my center is not the origin. So where's the point 0, 1? Is it this one?
No.
Is this one?
Yeah.
Yeah. So I'm going to put a point there. And then I'm going to use my color of choice to draw axes through there. And this one's going to be a little bit harder to do because there's actually these obnoxious numbers on the grid. And so you got to make sure you ignore them, kind of. Okay. We know our shape has to look the same. We know we're not doing reflection. We also are going 180 degrees. So you can imagine, do you guys understand that we're going to land over here in quadrant 4-ish, right? Okay, so first thing we're going to do is just go A, B, C. And we're going to write down their locations based on this being the origin. So C is the closest one. I'm going to do that one first. I have to go back to up 1. Back to up 1. Okay. Okay, for B, I'm going back or left 3, up 1, 2, 3, 4. So back 3, up 4. Can you guys figure out point A?
yeah.
Good. Okay, so be careful, it's just up 2, right? Not the 3 that's over here on the axis. Okay, so now once again, we can kind of think about, we know we want to be over here, so we know our signs are going to be positive, negative, right? Oh, sorry. Is that better? Okay, sorry about that. Sometimes I fall off the camera. Okay, and then sometimes okay, so let's think about C, because it's closest, right? So, and the thing is, okay, so do we want it to be over 2, down 1? Or do we want it to be over 1, down 2? So you kind of can play with it. Over 2, down 1. Do you guys like that one?
Yeah.
Because if I go over 1, down 2, do you see how it's not it's crooked? It's like, boop, boop, that's at 180 degrees. So this one is not the switch, it's just changed the signs. 2, -1. If you can figure out the pattern on one point, over 2, down 1. So what's nice with 180 is it does have that point reflection. Do you see how it's a straight line through the center? So that confirms that these two, like the next set of these coordinate pairs are the same numbers, just change the sign. So it's +5, -2, +3, -4. All right, see if you can do it. This is hard. This is really hard. All set? All right, thank you. Just make sure the lesson will go up as a video. The PDF is already there. Okay, thank you, dude. Okay, here we go. So now I got to be careful also. I'm going over 5, but I'm going down 2. And I'm going over 3, but down 4. So this was C prime. Now 4 is B prime. This is A prime. All right. Okay. So then, and once again, you can always kind of spin your paper to see if it makes sense to you, right? Does it look like it went 180 degrees? Okay. So that feels pretty good. The next thing it could just say is, hey, what is the coordinate pair for B prime, right? And that means we're not putting this answer. We got to go back to the origin and go to B prime. So it's over 3, down 3, right? Do you see how that's the true location on the coordinate plane? Okay. Over 3, down 3. What time is it, Chicklets?
Yeah, like 3 minutes.
Okay, cool. Okay. So this is what I need you to do possibly tonight. Can you just look through your first 3 days of notes and compare and contrast? And maybe just look at the different rules that are out there just to realize, okay, there's rules, but maybe I don't want to memorize these. But the translation rule is easy because it's add and subtract. That's a good one to know. The other ones you kind of have to be like, I know what reflection looks like. I know what rotation should like. These things are rigid motions. My triangles should be the same size. Those ideas. Yes.